Hey, how's everybody doing? It's Samansky. Got the cold going on, but we're going to do friction anyways, because that's the way we roll in physics. Party never stops. So, we got Calvin's mom trying to get Calvin to go to the bathroom. Well, let's just be honest, he's trying to take a bath. If you read Calvin Hobbes, you know he hates his baths. So, she is pulling on him with a force of 250 newtons at an angle of 50 degrees. So, I'm going to draw that in right here. So, we got bam, she's pulling with a force of 250 newtons at an angle of 50 degrees. So make sure your calculators are in degree mode, folks. And Calvin's got a mass of 25 kilograms. The lamp has a mass of 12 kilograms. How fast will they be going if she can keep pulling on him with a constant force at this angle for 12 seconds? Just for fun, let's make the coefficient of kinetic friction between the lamp and the carpet 0.6. All right, so if you can solve this problem, folks, you can pretty much solve anything I throw at you. So let's get it started by drawing a beautiful force diagram of Calvin and that lamp. So Calvin's got a mass of 25, the lamp's 12, so together they have a mass of 37 kilograms. His mom is pulling at an angle, so that means we got to break that up into force in the x and y component. So in the y plane, we're going to have 250 times sine of 50 degrees. In the x-plane, we're going to have 250 cosine 50 degrees. Again, be in degree mode. Gravity is pulling us down, so we got mg pulling us down. The carpet's pushing us up, so we've got a force normal here, and then friction is slowing us down. So that's our force diagram. Oh, don't forget balanced forces. He is not being flown up into the air. So now that I have this, I'm also going to list the other information I have at my disposal. So I know that mu is 0.6. I know that I'm looking for time. I know that... no, wait, I know the time. Time's 12 seconds. Cold's going to my head. Pen, 12 seconds. And I want to know the velocity. That's what I don't know. Now, looking at this, I've done enough physics to know the link between all my kinematics and my forces is acceleration. So I bet I'm going to need to know what that acceleration is. I'd also bet that Calvin's holding on, so his initial velocity is going to be a big fat 0. So this is all the givens that I'm going to start with. And since I'm trying to find acceleration, I got tons and tons of stuff with forces, I'm going to do a nice net force equation. So let's get that party started over here. Let's go, I don't know, red. So let's sum the forces. You can pick a plane, any plane. I'm going to pick the x-plane just because it's got friction in it. So that equals ma. Two forces, I've got force of friction minus 250 cosine of 50 degrees equals ma. Friction, I can quickly replace that with its equation, mu Fn minus 250 cosine of 50 equals ma. And now, I don't know the normal force, and I don't know the acceleration. So this is now hit kind of one of those unsolvable stages in my life. But I do have another plane I can work with. So I'm going to go, just take a little jog over here, and I'm going to look at the y-plane. I'm going to do a net force equation for the y-plane. Now in the y-plane I got three forces. I've got the 250 sine of 50. I've got another force normal pushing up, so that's positive. And then gravity is negative, it's pulling me down. Set that equal to ma, but in this case, since we have balanced forces, that's a big fat 0. So now it looks like this normal force just might be solvable. So let's do that. 250 sine of 50 plus Fn minus the mass, which is 37, times g, which is 9.8, equals 0. Solve for the normal force. The normal force equals 171.09. We'll go 9. That's my normal force. That's what I'm going to be bringing over here. Alright, so now we can go back to this. I'll go bust out the red again. And so now my mu value is 0.6. The normal force I just discovered is 171.09 minus 250 cosine 50 equals the mass of 37 times that unknown acceleration. So now I can solve for the acceleration Calvin's experiencing. Now before we give an answer, you should have a quick mental thought. And that thought should be, I wonder if the acceleration is going to be positive or negative. Well, the answer is it should be negative. Because if it's positive, that means that friction's winning the day, and definitely his mom is not dragging Calvin. Calvin is not budging. So if his mom truly is dragging him down the hallway, then we should see a negative acceleration. And if we do our math correctly, we do get a negative acceleration of negative 1.57 meters per second squared. All right, but that's not our answer. That is, though, going to get us from our net force stuff to acceleration, and then from acceleration, we can then start doing some kinematics. All right, so that's what I'm going to do right now. I'm going to do some kinematics. So I'm going to take the information that I know, and that is that my initial velocity is 0. The time is 12 seconds. The acceleration is negative 1.57, and I am looking for that final velocity because I don't know what it is. And again, this should give me a negative final velocity because we do have them going to the left, which is the negative direction. So if I set this up correctly, the equation I want to use is this guy right here, plus A delta t. Now it's a matter of substituting and solving. So 0 plus negative 1.57 times 12. So if I do my math correctly, I get negative 18.82 meters per second, which, by the way, is really fast. But hey, she is tired of him and she wants him in that bathtub now, and you won't understand that till you're a bit older. But fundamental thing is, if you can do this problem, if you can go through all these steps and you can see everything from breaking down the angled force into its components, to breaking out the force of friction and using the correct normal forces, to figuring out you need the acceleration to go to the kinematics, to supplying the correct kinematics equation to solve for that final velocity, which is what we're looking for, you are good to go. So, until next time, enjoy physics.